Welcome to the lecture 13 of the course CS213 Object Oriented Programming of the Kohat University of Science and Technology. In this lecture we will discuss polymorphism. In the previous series of lectures we talked about inheritance and the relevant concepts of inheritance, for example method overriding, and in this lecture we will try to build on those concepts and try to understand how we can use polymorphism, and we can build on the concepts that we learn in inheritance, and how can we use those concepts to understand polymorphism. There are some relevant topics that we'll also discuss, maybe not in this lecture, maybe in the following lectures. And the material, the book that we have been following is the same: Java How to Program Early Objects, Detail and Detail, and the relevant material can be found in chapter 10 of the book. There can be other tutorials that you can find useful. Some of the links have been given, some you can find other links online. Polymorphism stands for poly stands for multiple and morph stands for forms, and the concept occurs when one method name is in a method call can cause different actions depending on which type of instance it is invoking the method. Which means that, for example, in the given example we have a method draw, and we are using different objects to call that method, and the rectangle dot draw should draw a rectangle, circle dot draw should draw a circle, and a triangle dot draw should draw a triangle for us. The idea is that the name of the method is the same, but the output of the method is different based on the calling object. When one method name in a method call can cause different actions. Each method call is causing a different action. The first call is drawing a rectangle for us, the second call is drawing a circle for us, and the third call is drawing a triangle for us. So it depends on the type of the object that is calling that method, and the resultant action of the method will be according to the calling object. And this is the idea of polymorphism, where the behavior of the method call or the method changes in runtime. At runtime, the actual method corresponding to the instance type is executed. So it totally depends on the calling object. The same name method will give us different outcome. The method defined in the class whose constructor created the object. And we'll see in the examples that we will have a copy of this method in each of the class for which we have created this object, and the output of this method call will depend on whatever specifically we have mentioned or declared inside this method. We'll see in the examples that we will declare a method in a superclass. For example, this draw method can be possibly in a shape class, and the output of the shape will depend on the particular object of the shape. For example, if we have an rectangle of object of the shape, then the method should draw a rectangle for us. If we have a circle object of the shape, what will happen is we will have a shape class, and then we can have subclasses of the shape class. For example, there is a rectangle class, a circle class, a triangle class, all inheriting a shape class. Now each of these classes will have their own definition of the draw method, and as you can understand, we are using method overriding over here. We have a method in the superclass, we call that method as draw method, and we are extending or overriding that method into our subclasses. And each of the subclass, when we call the method on the object of that subclass, the relevant method or the execution or whatever the functionality we have defined in that class will be executed as a result of that method call. Relying on each object to know how to do the right thing in response to the same method call is the key concept of polymorphism. So we totally depend on the objects. And for example, the right thing for a rectangle object would be to draw a rectangle if we call the draw method on that object. Similarly, the right thing for a circle object would be to draw a circle when we call a draw method on that object. And the right thing for a triangle object would be to draw a triangle when we call the draw method on that object. But we can see that the behavior of the draw method is changing at runtime, and this is the whole concept of polymorphism, where the behavior of our code can change at runtime. And in this case, that is the method call that is changing at runtime. The same message sent to a variety of objects has many forms. For example, we are calling the draw method 3 times, and each of the time the same draw method gives us a different result. Same message sent to a variety of objects has many forms, and hence the term polymorphism, where poly stands for many and morphs stands for forms. Polymorphism allows us to use extensibility. With polymorphism, we can design and implement systems that are easily extensible. We can extend our system without doing many changes to our existing system. And this is what we discussed in our inheritance discussion. New classes can be added with little or no modification to the general portions of the program, as long as the new classes are part of the inheritance hierarchy that the program processes generically. We understand that we can, when we use inheritance and then we additionally use polymorphism, we can add our new classes without changing our existing system too much. New class can be added with little or no modification to the general portions of the program, as long as the new classes are part of the inheritance hierarchy. Of course, the class has to be relevant to the superclass that we are trying to extend. For example, we had a shape class in the previous example, and we were trying to extend, and we were using that shape class to draw 3 different kinds of shapes: a rectangle, a triangle, and a circle. If, for example, we want to draw a 4th kind of a shape, what we would do is to extend the shape class by that subclass, and in the subclass we will define and implement a draw method. So the shape should be any kind of a shape should be relevant, or any kind of a class should be relevant to the superclass, and in that case we will be able to plug that class right into the hierarchy. The only parts of the program that must be altered to accommodate new classes are those that require direct knowledge of the new classes that we add to the hierarchy. And we understand that when we use inheritance, and especially polymorphism, what we can do is the general portion or the general parts of the code are extended from the superclass, which can be shared by a bunch of classes which are extended from a single class or the same class. Then we add additional details that are specific to that class, and we only need to add those specific details. We saw this in the previous examples, especially in inheritance, that when we try to extend a class, we do not redefine the existing code. We do not need to define the existing members of the class that are already there in the superclass. We only add the members that are specific to our subclass, and that is what we need to do, and that is the idea of extensibility. By definition, if we try to define polymorphism, it is the ability of objects belonging to different types to respond to method calls of methods of the same name. And this is what we saw in our example as well, and we will look at another example, a couple of examples, to try to understand the idea of polymorphism better, each one according to an appropriate type specific behavior. The type of that method call was the object of a particular class that we were using to call the method, and the behavior of that method call was changing based on that call. So if we, for one object, the same method was drawing a different shape than for the other object. The program does not have to know the exact type of the object in advance, and this is dynamic binding that we are talking about. So this behavior can be implemented at runtime. This is called late binding or dynamic binding, and we'll look at this in upcoming examples as well. That our compiler does not necessarily know about the type of the object in advance, that what type of object is going to call a method. That is something that is done on runtime. Polymorphism enables you to deal in generalities and let the execution time environment handle the specifics. The general details are defined earlier than the execution time environment handles this, and what the specific thing that our code will need to do is that is done at the runtime or the execution time. So our code decides at runtime that what should be the output of a particular method call, and that call would depend on the type of the object. For example, we have a class animal that has a move method, and we extend that class. There is a subclass of the animal class, that is a bird class. The bird class extends the animal class and it overrides the move method. Of course, we are missing some syntax, but try to highlight the polymorphism example over here. And the move method of the bird class is printing a statement that it flies. So when we create an object for the bird class and we call the move method, the bird should fly. For example, we are creating a game, and in that game we have certain objects on our screen, and when we click on a bird, the bird should move, and the movement of the bird, as we understand, is flying. Every animal has its own kind of movement. Similarly, if we have a frog on our screen, and when we click on the frog, or there is certain event that results in the movement of the frog, so the frog's movement, as we understand, is jumping. So the frog should jump at a particular point that we have defined on the screen. And if we have some other kind of animal, in this case a fish, that is extending the animal, and as we can see, all of the three subclasses are extending the move method, are overriding the move method from the superclass animal. If you can guess what is can be the movement of a fish, obviously a fish swims, and you can add as many animals as you can think of. Each animal has their own kind of a movement. What we are trying to do over here is that we want to call the same move method on different objects, and we want the result to be specific to that object. So let's say we have three objects, each for each class: a bird object for the bird class, a frog object for the frog class, and a fish object for the fish class. And what we want is that when we call the move method on the bird object, the bird should fly. If we have a print statement, that print statement should be printed on the screen. And if we call the move method on the frog object, what should happen is the frog should jump, or print on the screen should appear on the screen. And similarly, when we call the move method on the fish object, the object should start swimming. So we are calling the same method, exactly the same method, on three different objects, and we are getting three different kinds of results. If we try to match this example with the definition of the polymorphism, we can see that it is the ability of objects belonging to different types. So we have three different types of objects to respond to method calls of methods of the same name, each one according to an appropriate type specific behavior. So each one of these method calls is giving us a different kind of behavior based on the calling object. And all of this happens at a runtime. We do not need to, and we will see this in the future examples as well, that this behavior of the method is displayed at runtime. We do not need to tell the compiler in advance that what will be the object we are going to call this method on. That will be decided at runtime. Let's look at another example to explain the concept of polymorphism in a little more detail. For example, we have a person class, and that person class has a bunch of subclasses, like say in this example a house chef, a KFC chef, a pizza chef, a takeaway chefs, and the person is working in a kitchen. If we consider the hierarchy, each type of this person belongs to the person class, but they are doing different kinds of job. So for example, if one of the person is working in my kitchen and I want to ask the person to prepare a dinner for me, or if I'm passing a message to this person to cook dinner for me. Now as we can see that the person class has two methods that are inherited by each of these subclasses. Those methods are a getName method that should return the name of the cook or the person, and then a cook dinner method, and this method should be inherited by all of these subclasses of the person class. And when I call a specific person from these classes, the specific cook dinner method of that class should be executed. For example, if I call a house chef class's cook dinner method on the object of the house chef, the method of the house chef should be executed. The program issues the same message, that is the cook dinner message, to each person object, but each person has its own way to cook for my dinner. A KFC chef will prepare a special kind of KFC chicken for me. A pizza chef would prepare a pizza for me. A takeaway chef would prepare a different kinds of a dish that is can be taken away. But the response of each object is unique, and that is because we use polymorphism over here, where the response of each of these objects is specific to the class where the cook dinner has been defined in. The same message in this case, the cook dinner sent to a variety of objects, has many forms of results, and that is the idea of polymorphism, where we are getting here in this example 4 different kinds of results by calling the same cook dinner method, only because we are using the different object. We are calling that method by different objects. So a house chef, if I call the method on the house chef object, I will get a different response from the same cook dinner method when I call the method on the pizza chef object. For example, if you go into the details of the person class, the person class has a getName method that gets the surname and the first name of the person, and that a cook dinner method, and that method will ask the person to cook food or dinner. And an ordinary person like me prepares dinner using a microwave. So if we look at the implementation of the class, so we have a class person, then there are 2 instance variables of the class person. These are kind of protected variables, and then a cook dinner, and that person is expected to cook dinner using the microwave. So that is person in this case is not an expert, so that he or she will use in the easiest way of cooking dinner. We have instance variables and methods in this person that will be inherited by all the kinds of persons that we looked at in our example, and the dinner here in this case will be a relatively easier one for us. And whatever when we declare an object of the person class, so it is expecting a name from us, and the name has 2 parts. and then if we call the getName method and we call the cookDinner method using that object, we'll get this output. So we'll get the name of the person and we will get the type of the dinner that this person has prepared for us. Now we can look at the message call here, the method call here, the kind of message we are sending to the person. And we'll see in the next few slides that we will call the same method using different objects, and it will give us a different kind of a dinner. In this case it is giving us a microwaved dinner, but we'll see that we can get better kind of dinners from the same method. So we'll look that in the next few slides. In this case, our kitchen now has a house chef person. We have inherited the method getName from this person class to get the name of the chef. Then we have an additional method inside this class, that is the cleanKitchen method. Now this method was not there in our super class. This is something specific to the house chef class. And we said that we can add additional functionality to our classes along with the functionality that it is extending from the super class. So from the super class it is extending the getName method and the cookDinner method, while it is adding another method, the cleanKitchen method, to clean our kitchen. The overridden method in this case is the cookDinner method, and when we, as you can see, the house chef extends the person class. There is a constructor that is initializing these two variables, and we can see that the variables have been passed to the constructor of the super class. There was a constructor in the super class in the person class which was initializing these two variables, so we do not need to worry about initialization of these variables in this class. We can simply pass on these two variables to the super class's constructor, which will take care of initializing these two variables. That is the beauty of inheritance. Now we are extending or overriding a method from the super class, that is the same method, the cookDinner. The signature of the two methods should match, but it is doing a different function. It is roasting a chicken. The previous method was microwaving a dinner for us, but in this case the house chef is roasting a chicken for us with a potato. And then there is another method that is specific to this person, that is cleaning the kitchen. And what should happen is when we call this method using an object of this class. So now we have an object that is initialized using the reference to the subclass, that is the house chef. Our name is passed on, which will be eventually passed on to the superclass's constructor. When we call the getName method using this object, now it is the same P object that we initialized using the person class, but at this time it is using a referencing to this our subclass. And this is the output that we should get from this method call. In the third scenario, our kitchen has a pizza chef person now. As in the previous case, we have inherited the method getName from the person class, and we have overridden the cookDinner method from the person class, but we have a different implementation of the cookDinner method in this case. As we can see that we have extended the person class, that is, and we are initializing the name of the person the same way as we were doing in the previous two cases, or in the previous case, where we are passing the two variables to our superclass, which will take care of the initialization of the two variables, and we are implementing the cookDinner method. In this case, the person will cook a delicious pizza for us, and we using the same object. For example, we are referencing to the subclass pizza chef class. We are passing a couple of values, that is the first name and the surname of the person. We can get the name, But when we call the same cook dinner method, it will generate a different output for us in this case, which is different than our two previous cases. And this is again explains the concept of polymorphism for us, that we are calling exactly the same method, but we are getting a pizza this time. In the previous case we are getting a chicken, a roasted chicken, and in the case before that we were getting a simple microwaved dinner. If we look at the next two scenarios, where in one case we have a KFC chef person with exactly the same inheritance. For example, it is inheriting the get name method and it is overriding the cook dinner method. It has no specific method of its own. And we can see that when we call the cook dinner method using an object of the KFC chef, an object that is referencing to the KFC chef, we get a KFC dinner in this case. So exactly the same method that we call, but we are getting a different result. We are getting a different name and we are getting a KFC chicken in this case. Similarly, if we call the same method using an object of the takeaway chef, we will get a different dinner in this case. We are using the same get name method is inherited, the cook dinner method is overridden from the superclass, and the takeaway chef makes fried rice for us. If we call the method cook dinner using an object of the takeaway chef, it will get us a different name, that is the name of the takeaway chef, and it will get us the fried rice. So we were calling the name the same cook dinner method, and we got 5 different types of dinners for us. In the first case we got a microwave chicken, that was a microwaved dinner, that was a simple dinner. Then in the second case we got a roasted chicken. In the third case we got a pizza, and the fourth case we got a KFC chicken. In the fifth case we got a fried rice by calling exactly the same method, and that is the idea of polymorphism.